Hi, in this video, we want to take a look at add variable plots. Okay, so the situation is that we have multiple predictor variables. We want to build a linear model to predict one target variable, and we have a whole bunch of different predictors. Okay, so a funny situation about this that doesn't come up in simple linear regression is that if I have a predictor variable, its informative value may have already been contributed to, like the value that I've got in that one variable may have already been captured by other variables that are in my data set. All right, so like the idea here is, let's say I've got 3 predictor variables. Let's say these 2 can predict this predictor variable very, very well. Well, if these 2 can predict this one very, very well, this one's useless because all the informative value of this is captured in these 2. Okay, well, when I get into 4, 5, 6, 10, 20 predictor variables, it gets even more complicated. And so every possible combination of other predictor variables can have the informative value of another predictive variable. So when I'm in this situation, I don't want to use a predictor variable whose informative value is picked up elsewhere, because it'll make, number one, it'll make the model more complicated. Number 2, it's going to befuddle the values of the coefficients. So what's going to end up happening is that the values of the coefficients aren't going to be exactly what they really should be. So when I interpret the slope, I'm going to come up with the wrong conclusions. Worse than anything else we've got going on is that when I do this, my model is prone to overfitting. Okay, so an idea you need to think about if you go into machine learning or statistics, when I build models, the more predictor variables I have, the more prone to overfitting I am. And you're always going to be in kind of like this balance between trying to get maximum information out of your data, but don't overfit. You know, you don't want too many, you don't want too few predictor variables. In data science, we are always in a Goldilocks problem. We don't want too much, we don't want too little, we want just right. Okay, so the big concept here, this is something that we really need to like mathematically, like kind of trust me on this one, is that if I have a collection of predictor variables, the informative value of some of my variables may have already been captured by other variables. And therefore, I don't want those excess ones because they'll just cause problems in my model. We want the simplest model we can for the informative value that we can get. All right, so let's go ahead and let's go through an example. So first thing we're going to do, we're going to read our data. This is the New York City data with restaurants. We looked at it before. And something I'm going to do, I'm going to go ahead and sort my data by the target variable. So I'm using order to figure out which observations have the least to the most for the target variable. And then I am sorting all the data that way. And then I am setting it up so that the row names are equal to the names of the restaurant. That way, when I start looking at my diagnostic plots, it's easier for me to identify which observation has any like peculiar features. And something I always do whenever I'm modeling, for my plots, I color all the points by a variable that is important to me as I'm working through. And the target variable is almost always important, so I color by the target variable. All right, so let's go ahead and build a multiple linear regression model. So what we're going to do, we're going to say that price depends on decor, food, east, and service. Now, this example is from a textbook, and you'll notice that I actually have it in a very specific order. I went decor, food, east, then service. That's not the order in the data set. That's not the order in the textbook. I was doing model exploration, and before I made this document, I concluded that decor was the most important, then food, then east, then service. So I put it in that order. Why do I do this? Because when I run through my NOVA test in a moment, it's going to be checking to see about the idea of adding these variables sequentially. And if I feel that decor is the most important, then that is the one I want to start out with. If food is second most important, then I want to check that one second, and so on. All right, now, summary. What the summary output says is it evaluates if a coefficient is equal to 0. It's doing a hypothesis test, and here are the p-values for these coefficients being equal to 0. And so if I get a small p-value, I conclude that the coefficient is not equal to 0, which is saying, in a way, things get a little bit tricky and sticky on this, but it's saying that the variable does not belong in the model if the coefficient is equal to 0, because if it's 0, then it wouldn't be in the equation. All right, well, let's do ANOVA. ANOVA is checking to see, should I add this variable to the model that contains all of the previous variables? So here, it's asking, should we add decor to the constant model? So that here we have the y-intercept only, which would be the mean of y. Should we add this? Well, yes, we should. The null hypothesis is that the two models are equally informative, and so then we would go with the simpler one without the variable. Here, should we add food to the model with decor? Yes, we should. Should we add yeast to the model with decor and food? I conclude that we should. Now, it will depend on, now some of you have already done things like, Bonferroni corrections for hypothesis testing. I'm not going to get into that here, but when you start getting into the p-values are closer to your cutoff, if you're making a hypothesis test correction on your alpha, you may or may not include yeast. It's up to you. You're the practitioner. Now, when I get the service, this hypothesis test is asking, should I add service to the model with decor, food, yeast? All right, this indicates that I should not. That service does not improve the informative value of the model if I add it in. It would make the model more complicated. It could befuddle the values of the coefficients, and it might contribute to overfitting. In this example, it's not going to overfit because of the ratio of data that we have ratio of observations to predictors. It really makes overfitting not really an issue, but still, if we don't want it, we don't want it. All right, so let's go ahead and run through our diagnostic plot. We're used to doing this at this point. All right, so I don't really see a pattern going on, except I do kind of see a color gradient going this way. When the fitted values go along here, the color gradient should be more horizontal and less slanted. So that's something just to be kind of mindful of. If I see other problems, I might want to start digging in on finding another way to deal with it. All right, so it looks like we've got some skewness going on. So everything's looking good over here, but then boom, it's this way. So that's something to be mindful of as we go forward. All right, here are square root of the standardized residuals. Because of the absolute value, it's kind of like there's like a folding of the residuals, which is, I'm just seeing it as being consistent with the previous residual plot. All right, and we can see that one of our extreme values has a greater cook distance value. So that's something we might want to look at that individual data point. I don't in this example because I'm trying to get to a different point on this. And all right, so leverage versus residuals. We can see that I got 2 points way out here by itself. That's something I would probably want to look at these 2 points. Okay, this will be those 2 points also. All right, so what I want to do now, I want to go through, I'm going to find the, I'm going to look at scatter plots of one predictor variable and my target variable. And we just want to go, and then what I'm going to do, I'm going to do add variable plots. And I want to compare and contrast these plots with us. So let's go through. Let's get down here. All right, so here we have decor and price. All right, so this scatter plot tells me if I was to have decor by itself, would it be a worthwhile predictor for price by itself? Well, yeah, I can see that. Now, when I get down here, this is the added variable plot. What this is asking is if I have a model with the variables besides decor, can I improve the model by adding decor? So here I've got decor given the other predictor variables. Here I have price given the other predictor variables. Now, if I see a slope that's not horizontal, then that indicates to me that I want to add decor to the model that has all the other predictor variables. So something that's important about this. This scatter plot tells me if decor by itself would give me a worthwhile model for simple linear regression. Here, the add variable plot tells me, should I add decor to the model with the other 3 predictor variables? Here I conclude yes. Now let's scroll down. Let's look at food. All right, when I look here, what this is telling me, if I was interested in the model, food predicts price with 1 predictor variable, would that be a worthwhile model? Not as good as decor, but I see some informative value in there. All right. Now let's do the add variable plot. Now the add variable plot asks the question, should we add food to the model of decor, service, east? And here I see a slope. It's not as strong as the one with decor, but I see a slope. Therefore, that one's probably going to be, yeah, I feel like it would be worthwhile to add. So these are 2 very different scatter plots. One is looking at the model food predicts price. Here, this is giving me a visualization of should I add food to the model with the 3 other predictors. Now for east, remember east has 2 values, 0 and 1. So on this one, I don't actually want a scatter plot. I want to look at the box plots. And basically what I want to do, the more of a difference I see in the boxes, I focus on the boxes. If I see this, then I very much want the east variable in there. If I see this, where they're next to each other, I'm not feeling it for east. So I see something like this. I see a little bit of a vertical difference, but I see that the median lines intersect each other's boxes. So here, now there may be a statistically significant difference between the 2 groups, but operationally, it may not be that big of an impact. So, you know, I would use other things to make a decision on this, but I would be leaning at this point to not include east. Okay, so now let's do the add variable plot. And here we can see that we've got 2 groups. And this, you know, these 2 groups will correspond to 0s and 1s for east. But this is east given decor, service, food. And here this is price given food, decor, and service. And I don't see much of a slope. So here I'm feeling that east isn't adding that much to those when I have the 3 other variables anyway. Now service, let's take a look. When I look at service by itself, I mean, that's a straight, you know, that's a line. I'm pretty good. I feel like that one's better than food, actually. But when I get to the add variable plot, that is as flat as can be. That's flat as a pancake. That is as flat as Kansas. So what this is telling me is that it really would not improve my model. It might actually hurt my model to add service when I have decor, food, and East already in my model. So the informative value of service is already captured by these three. This means that service has nothing to contribute. So if I was working on this to model the price of food, I would not want to include service because service really is accounted for in the other variables. So if I was to include service, I might overfit. I might mess up the coefficients, and so that I can't trust the interpretation of the coefficients. And it just makes the model more complicated so that someone with a weaker math background will not want to look at it. All right, so so the point of this video really comes down to these two scatter plots. Here, this shows me that service by itself is a worthwhile predictor variable when I look at it in isolation. But when I consider a model that has the other three variables already, then service doesn't have anything to add. So think of it, okay, I'm gonna go with a sports analysis. Guys always do this, but think about like in football. If I have a star quarterback, is it gonna help me to get a second star quarterback? Well, a little bit, when he needs to come off the field every once in a while. If I have a star running back, does it help me to get a second star running back? Well, a little, but would be better to go focus on other positions, on other aspects of the team. Yes, it would. If I've already got something already taken care of on my team, on my organization, repeating that strength isn't going to give me as much bang for my buck as including where something to shore up a weakness. And so service is kind of like a redundancy in that. The strength of service is already captured elsewhere. So I would not be including it in a model. All right, that's all I've got for you. I hope you're doing well. Take care and goodbye.